Okay, let's just dive right into this explainer. We're going to break down the exact step-by-step communication flow that happens behind the scenes every single time we navigate the internet. So, if you're an IT student, an aspiring network engineer, or honestly, just someone who wants to peek under the hood of the digital world, understanding this specific server journey is absolutely foundational.
To really grasp the problem space here, we've got to look at the fundamental communication gap between us humans and our computers. See, humans, we're all about names. Whether it's a country, a friend, or a website, we prefer words, like yahoo.com. Computers and networking devices, on the other hand, strictly use numbers. They literally need IP addresses to actually talk to and identify each other over a network. And this brilliantly illustrates exactly why network engineers built the Domain Name System, or DNS. Its entire job is to bridge that communication gap by resolving those human-friendly domain names into machine-readable IP addresses. Now, technically, you don't have to type in a domain name. You could just type a raw IP address into your browser, well, if you had a bunch of them memorized. But with millions of websites out there, engineers developed DNS to do all that heavy lifting for us.
So, the absolute easiest way to think about this, it's a digital phone book. I mean, when you want to call a local business, you don't look up a random string of numbers first, right? You look up the business name and the phone book hands you the correct number. DNS does exactly that. It is the ultimate directory for the entire internet.
All right, here is our roadmap for tracing a single query from your browser through the whole DNS hierarchy and back again. We're going to cover names, numbers, and DNS, the role of the resolver, querying the root server, top-level domain servers, the authoritative name server, and finally, caching and final delivery. Number 1. Names, numbers, and DNS. Let's begin the journey with the user's initial request. When you open up your web browser and type in a domain like yahoo.com, your computer's first instinct is actually to check its own local cache memory. It wants to see if it already knows the answer. Your operating system is essentially checking its recent history. If it finds that matching IP address locally, boom, the journey ends right there. But what happens when that cache is totally empty? Number 2, the role of the resolver. It's time to escalate the request. Enter the resolver server. This is usually your internet service provider, or ISP. Think of the resolver as your highly active coordinator for this whole journey. When it gets your query, the very first thing it does is check its own cache memory. If it still can't find that IP address for yahoo.com, it steps up to act on your behalf, heading out into the broader internet to track down that number for you. Number 3, querying the root server. We are going to the top of the DNS hierarchy. Now, think of the root server as the initial traffic cop in this network flow. The root server doesn't actually have the final answer. It has no idea what the exact IP address for yahoo.com is. But it knows exactly who the resolver needs to ask next to get closer to that answer. And here is a truly fascinating detail, especially for the IT students out there. There are exactly 13 sets of these strategically placed root servers globally. They're operated by 12 different organizations, and get this, each set possesses its own unique IP address. They basically form the top-level anchor for all internet routing.
Notice the hub-and-spoke flow happening here. The resolver is doing all the legwork. It pings the root server looking for yahoo.com. The root server bounces a referral right back, essentially saying, hey, I don't know the IP, but this is a .com address, so go check with the .com top-level domain server.
Number 4, top-level domain servers. Let's move to the next level. So the top-level domain, or TLD server, manages specific domain extensions. They store the address information for top-level categories, your .coms, .nets, and .orgs. So for our yahoo.com example, the resolver specifically queries the server that manages the entire .com domain space. And just like before, the TLD server is basically acting as a middleman. In step 1, the resolver asks this TLD server for the IP address. In step 2, the TLD server responds by sending the resolver just one step further down the chain. It directs our hardworking ISP resolver to the absolute final level of our hierarchy. Number 5, the authoritative name server, the final stop. The authoritative name server is exactly what it sounds like. It's the final boss of the DNS process. These servers are responsible for knowing absolutely everything about their specific domain, which crucially includes holding the true exact IP address we've been hunting for. We have finally hit the target. The resolver queries the authoritative name server, and because this server is the final authority, it successfully responds by handing the exact IP address for yahoo.com right back to our central hub, the resolver. The data has been found.
Number 6, caching and final delivery, completing the transaction.
Now, the resolver hands those numbers back to your computer, successfully bridging that communication gap we talked about at the very beginning. Because your computer finally has the numerical IP address, it can communicate directly with Yahoo's web server and retrieve the web page you asked for.
But crucially, and guys, this is a vital concept for efficient network flow, the resolver then memorizes this answer. It stores that newly found IP address in its own cache memory. This optimization is absolutely critical because it ensures that if you or anyone else using that same resolver ask for yahoo.com again, the resolution is instant. The resolver won't have to bother the root, TLD, or authoritative servers again.
This whole process, it all happens in a matter of milliseconds. But understanding this exact, structured flow is absolutely fundamental to mastering network engineering. So the next time you hit enter on your browser and a page instantly appears, ask yourself, can you visualize the invisible, multi-server journey your resolver just orchestrated to bridge that gap between names and numbers? It's a seriously incredible piece of engineering happening right beneath our fingertips. Keep that visualization sharp, and thanks for exploring this network journey with me today.